Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at limiting reactants. So right up top we have this paragraph. There's some really important information in here. It introduces limiting reactant and excess reactant. So it describes them through the problem. So if you had 10 moles of propane, you would need 50 moles of oxygen. Remember, we know that because everything in a chemical reaction is based on the mole ratio, which is equal to the coefficients. So 10 to 50 is the same as 1 to 5. You just multiplied everything by 10. So we know that if you had 10 moles of propane, you would need 50 moles of oxygen. However, if you had the case where you only had 20 moles of oxygen, you would not be able to combust all 10 moles of propane. Therefore, you are limited by the amount of oxygen you have. You cannot react all of the propane because you do not have 50 moles of it. So that's what we call a limiting reactant. You are limited by the amount of oxygen you have. Propane is what we call the excess reactant. It's excess because you have extra. You're not going to be able to react all 10 moles of it. That means you're going to have extra. So in question one, we're looking at excess reactant versus limiting reactant. So the first problem, we're thinking about how many moles of propane can be combusted with 20 moles of oxygen. So just like in the last ChemQuest, this is a multi-mole conversion. So you start the same way. You start with your T. What you know goes in the top left. We want our moles of oxygen to cancel, so they go in the bottom right. Then we put our moles of propane, moles of C3H8 on top because that's what we're converting to. These values right here, the 1 and the 5, remember we can take those values from the coefficients because the coefficients equal the number of moles. So when you solve, you find 4 moles of propane. Next, we have our part B. Part B, we're trying to figure out how many moles of carbon dioxide we need. After we have 4 moles of propane. So again, it's just a mole to mole conversion. So you start the same way. What we know from part A goes in the top left, 4 moles of propane. You want your moles of propane to cancel, bottom right, moles of carbon dioxide on top. You need to plug your values in from the balanced reaction. When you solve, you should get 12. Make sure you get 12. If you don't, ask me when you come to class. Part C. So part C, we need to verify that if you have 12.5 moles of propane and 63.2 moles of oxygen, then propane is the limiting reactant. So we know these are the values we're starting with. So what we need to do is we need to do a mole to mole conversion. So then that way we can compare the amount of oxygen and the amount of propane we have. So the first conversion we do is we convert moles of propane to moles of oxygen. That tells us exactly how much oxygen we need if we have 12.5 moles of propane. We do the same thing for oxygen. We're starting with 63.2 moles of oxygen. So if you start the same thing, we need to convert to propane. That way we can see how much propane we have. Remember guys, these values I left out. You need to find the values from the periodic table, not the periodic table, from the balanced chemical equation. These are your answers. Make sure you get these. So in this case, we know that propane is the limiting reactant because it tells us we need 12.64 moles of propane. However, we only have 12.5. So we do not have enough propane because it tells us we only have 12.5. We need 12.64. So next we are looking at question 2. So question 2 gives you a balanced chemical equation, and then it tells you how many moles you have of the reactants, and then you need to figure out which one is the limiting in the first problem. So we did the same thing we did in 3C. We started with the moles, and then we converted to the opposite one. So again, remember these mole values, the coefficients, they come from the coefficient. These values of moles come from the coefficients in the periodic table. Same thing down here. We converted the moles of sodium phosphate that they gave us. I did not put the values in. You need to find the values from the periodic table. Make sure you can get these answers, the same answers that I got. We know that the limiting reactant is magnesium chloride. We know it is because we need 0.975 moles, but they only give us 0.75. So that means magnesium chloride is the limiting. If magnesium chloride is the limiting, that means sodium phosphate must be the excess. Being able to determine limiting versus excess is important for the second question. The second question is asking us how many moles of excess reactant are left over. So that is simple. You take the moles that they gave you, however much you had, and then you subtract by however much is used. Then the answer, what's given to you, 0.15, that's the moles that's left over. That's what we did not use. And then lastly, part C. Part C is asking us about the moles of sodium chloride will be produced in the reaction. So to do this one, you need to convert the limiting reactant. It's important to make sure that you convert the limiting reactant because the limiting reactant, it means that so it's important to convert the limiting reactant because you're limited by that. You cannot produce more than what the limiting reactant has. So if you were to use the excess reactant to make your conversion, then you are just going to have, your values are going to be too big. So it's really important to make sure you pick the limiting reactant. So that's what I did here. Magnesium chloride is the limiting reactant. We convert to sodium chloride. Remember guys, I plugged the moles in so they cancel. These values come from the coefficients. Plug them in. You should be able to get 1.95. If you don't, please circle it. Ask me when you come to class. Lastly is question 3. So I apologize. I realized that when I started doing this problem out that there was not enough room for it. So please, you can do this on a separate piece of paper and staple it. So the first thing is you need to find the balanced chemical equation. So I did out the chemical equation for you. Remember, if you get stuck here, I did the crisscross. I did it out for you. Make sure you ask me if you can't balance the equation. Part B. So part B is finding the limiting reactant. So this is the same thing that we have been doing. Except that this time they gave us grams and not moles. So the first thing you need to do is to convert to moles so we can compare. So that's what I did. The masses are over here. Remember, the masses are from the periodic table. You just need to add up, multiply by the subscripts. So I converted to moles. After you convert both of these to moles, you need to pick one so we can compare. So remember, you have to do the mole to mole conversion so we can figure out how many moles of calcium sulfate we need. Remember the reactant. So remember these values right here, the 1 and the 2, these are the coefficients from the balanced equation. We find out that we need 0.195 moles of calcium sulfate. This means that sodium iodide is the limiting reactant. We know this because we need 1.95 moles of calcium sulfide and we have 0.25 of it. So that means we're going to have extra calcium sulfate. So that means calcium sulfate is the excess and then sodium iodide is the limiting. Next, we are looking at C. So C is asking us to find the number of moles of each product. So remember guys, number of moles of each product, remember it's important to use the limiting reactant. We use the limiting reactant because the limiting reactant is when the limiting reactant is over, that's when the reaction is going to stop. So we can't use the excess. If you use the excess, your moles are going to be too large. So again, this is just a mole conversion. So we plugged in what we know in the top left. We want our units to cancel, so we put moles of sodium iodide on the bottom, and then what we're converting to on top. And the first one is calcium iodide because that's the first product. The second product is sodium sulfate, so that's why this is here. You do find that you have the same number of moles of each product. The number of that will happen quite a few times, especially when the coefficients for the reactants are the same. The important thing to remember though is even if you have the same moles, you have a different amount of each substance because remember the mass on the periodic table is 1 mole and everything's mass is different. So in part D, what you have to do is you have to convert from moles to mass. So we take the 0.195 moles of calcium iodine, we multiply by the mass on the periodic table. Remember guys, mass of the periodic table is just found by adding up the masses and then multiplying by the subscripts. So then we do the same thing for sodium sulfate. We converted to grams. So this is the mass of sodium sulfate, again found from your periodic table. Please, if you have any questions from this, make sure you circle and bring it. This question is a very important question, and I know it's long. What you guys are about to do now is in question 4. Question 4, you guys are going to do the same steps that you just did in 3A, B, C, and D. However, the steps are not labeled for you. So walk through the same steps, use my work to help you. I already put the balanced chemical equation there for you guys. That way, if anyone's still struggling with this, at least you have the balanced chemical equation and you can still attempt the problem. Remember, I showed the crisscross. If you need help balancing equations, make sure you ask me. There will be a problem like this on your quiz. Please, if you have any questions, circle them, bring them to class. I hope everyone has a good day.